Hello everyone. Today I'll be covering the AMGM, which is one of the most important topics in algebra. Whether that's Olympiad or just academic algebra, you have to use it somewhere throughout your math journey. Essentially, this AMGM so-called thing is derived from this smaller, I guess you could call it a lemma. It's very small, so lemma. It's known as the trivial inequality. So basically, for any integer x is in a set of real numbers, x squared must be greater than or equal to 0. So if that's true, then we could also say that for any value x and y, root x minus root y, the whole squared, must be greater than or equal to 0. Okay, let's expand this. We will get this. Let's not put the inequality sign yet. Oh wait, no. Yeah, sorry. We could. Put the negative part on the other side. Divide it by 2. You will get this. So essentially this part is the AM, standing for arithmetic mean. Because, well, just like in statistics, right? You add in 2 values and then divide it by 2 to get the mean of it. Whereas this is the geometric mean. There's also another way to derive this formula. It's with a circle. But I'll leave that as a way for the viewer to research more about this topic. But essentially, it involves around manipulating the circle's radii and stuff. It's very interesting. Okay, we'll now do some problems with this inequality that we've just, with this inequality that we've just gained. Also, just as a general formula to sort of generalize everything for the AMGM, it's x1 plus x2 plus x3 plus so on, xn. For the left-hand side, right, for the greater than or equal to side, you could just memorize that as the formula for calculating the mean of something in statistics. So there are n amount of terms. You divide it by n, you'll get the mean of every single term. And on the right hand side, this part's a bit different. It's basically the root of n, and in the root, you'll have the product of every single term. 3, so on, extend. Voila. Okay. Now that that's been generalized, we'll first try out an example before we get to more harder problems. Just one problem, actually. We'll only be solving one problem. Okay. Prove that AB plus BC plus CA is greater than or equal to 3. Okay. This looks very simple, right? Whenever we see a problem regarding inequalities, we'll first look at the sign. If there's an equal sign over here, it's an implication that we'll have to use the AMGM or other inequalities that you'll see throughout your math Olympiad journey. You'll see things like the myriad inequality. I'm not sure if I'm pronouncing that right, but that. You also see the Cauchy-Schwarz. But essentially, if you see something like this, if you see the sign, you'll have to mostly use the AMGM. Okay, first try to work this out and then resume the video. Pause the video now. Okay. We'll just straight up apply the formula for the AM GM. Oh, wait. Oh, sorry. Oh, wait. This part's actually wrong. Okay. Whoops. Okay. Pause the video again and try again. You probably didn't get it because I wrote the question wrong. My bad. Okay. Since you're back, let's try to solve this together now. AB plus, we'll just straight up apply the AMGM in here. So we'll count this as one term, second term, third term. So AM, we divide that by 3 because we have 3 terms. On the left-hand side, we will have cube root because there are, remember, 3 terms. And that would be the product of this. And notice that this is a cyclic product, which means it's just cycling around AB, BC, CA. It's like a little cycle, right? From A to B to C. AB, BC, AB, BC, CA. Voila. So we will have 2a's, 8 times a is a squared, b squared, c squared. So we will have this in our cube root, ABC the whole square. And to conclude, we will send the 3 to the right hand side, to which we will get our desired answer. Okay, let's move on to a harder problem. Okay. Okay, pause the video if you want to try by yourself. If you don't want to, that's completely fine. Okay, let's start solving this. So, well, this looks a bit strange, right? The sign is flipped, so the 1 part must be the AM part. And this part has got to be the GM part. Because remember, well, this part's supposed to face the AM part, the arithmetic mean part, because it's greater than or equal to the geometric mean. So, we'll somehow have to work out with that hint. Okay, as you can see, we are only given these terms to just sort of prove this inequality with. So let's try to, well, use those terms. And if that doesn't work, we'll have to go through a more rigorous work. So let's count this part as 1 term, second term, third term. So by the AMGM, we could write everything like this. Okay, before we move on, let's denote this, the product of these things as x, because, oh, it's gonna be very long to just write out the whole thing. Okay. Well, as you can see, we already have the product part here, because this is the product that we want, and we have the product in the cube root, so I guess we'll just have to sort of solve the left-hand side of the inequality. So by the AMGM, we have this. So on the left-hand side, a plus b plus c minus 3, 1 over a, 1 over b, 1 over c. So, one more thing. If we were to just, well, cube both of the equations, we'll get the thing that we want, which is this part, because we already have the product and the cube root, so that's what we're trying to do. But if we were to just cube it right now, it's gonna be complicated, of course, because the left-hand side hasn't been sorted out yet. It still looks very complex. So we'll try our best to make the left-hand side look more simple. And how can we do that? How can we literally turn this term into something simpler, into a constant preferably? Well, we could apply the AMGM into these things. So for this part, by the AMGM, we will have this, voila, AMGM. Times that. Oh no, wait, there's a gosh, I'm actually an idiot. In the question, they also gave you this. You could use this, so ABCD is equal to 1. That's without that, you probably won't be able to solve the question. So, geez, my bad. ABC is equal to 1. So, for this part, that would just be this, which is equal to 3. So, that part's been solved. We also see some variables here, so we'll try to cancel those things out with the same principle, the same inequality, the AMGM. 1 over ABC times that by 3 to remove out the 3 from the left-hand side. You will get 1 by 1. Cube root 3. To which that is equal to, 3. Okay. Now, since we have the sort of the lower bounds for these, we could sort of just apply them, put them in this part, because regardless of whether they're lower bounds or upper bounds or any value that sort of validates the terms with the AMGM thing, we could use it because remember, we still have these 3 terms that would sort of make sure that they're not actually less than or equal to this part. So it would keep the inequality, it would keep it true, you know? Okay. Let's put that in here. We'll substitute the values. 3 minus 3. A plus B plus C is less than or equal to 3, so we'll put the 3 in here. The harmonic sum of A plus B plus C is less than or equal to 3 again, so we'll put that here too. To which that is this 3 by 3, 1. So the cube of 1 is just 1. And on the left-hand side, we have x. And remember, x is the product of the 3 terms that we initially had. So we could just write it out like this. Give me a second. By b. B minus 1. By c. And voila, we have proven the question. So yeah, that's pretty much it. And as a summary, you'll just need to sort of get used to applying this formula for the AMGM, x1 plus x2 plus so on to xn divided by n is always greater than or equal to the n root of x1 times x2 times so on until xn. And that's pretty much it. If you want more problems, you could probably look them up on the AOPS website. And as always, good luck on your Olympiad journey. Thank you.